Okay, we've got a two-part question here, and we'll do them on the two slides. And the first part is on the screen in front of you. So we've got people wanting to build a boundary fence, and it's saying that 10% of its fence palings are bent, and bent palings should not be used. So these fence palings are being sold at a cheaper rate. So Elizabeth and John buy 150 and assume that the fence palings are randomly selected. Okay, so there's some lots of good information there. So we're assuming that they're randomly selected. We've got 10%, that's a probability. We've got a total amount of 130, and they're buying 150. Okay, rightio. So they need 130, but they're buying 150, obviously, to because they're worried about this 10%. So it says here, if the random variable x represents the number of non-bent fence palings in a random sample of 150, state the name of the distribution x will have and value for each parameter. Okay, so basically what they're actually asking here is what type of probability distribution are you going to use? So it's we're not seeing any means or standard deviations or anything like that, and fence palings are discrete. So we can see here that the data is discrete. So that's the first thing. So that leaves us with either a binomial, a Poisson, I better spell it right, or discrete random variable. Now, with a discrete random variable sort of question, you are more than likely going to get a table given to you. So while they talk about random variables here, then they're not giving us any sort of information from which we can determine each of the values of that. I mean, we could use a binomial or a Poisson to do that, but then we're kind of defeating the purpose. There's no rate here. So I don't think it's a Poisson. You've got two options here with the binomial. You've either got that they're bent or they're not bent. So I think we're looking at a binomial distribution here. So when it says fully justify why x has this distribution, so it's saying state the name. Yep, okay, so we've got a binomial distribution. That's the first thing. And then it says state that x will have and the value of each parameter. Okay, we can do that and fully justify why x has this distribution. So you need to go through all the reasons, and this is why it's important. You need to know the reasons for each of these distributions. So first of all, a binomial distribution, it's there's independence basically, and this is implied in the information that you're given. So, and the implication here is that assume that the fence palings are randomly selected from a large stack of palings, and each paling is kind of like independent of one another. So buying one paling shouldn't really affect you buying another paling. So you could imply it in question to do with the to do with the palings itself. So not a lot you can really talk about in terms of that one. The second thing we can talk about is that we have a fixed number of trials. So that's quite important. So fixed number of trials, and that our n value is equal to 150. Okay, so that's this number here. They've bought 150 palings. Just picking a different color here. The probability is constant. So probability of getting a bent paling, basically, paling is equal to 10%, which equals 0.1, of course. So obviously a non-bent paling would be, so non-bent would be equal to 0.9. And the thing is that it's that probability, you should probably also put in there, is that it's constant. They're not saying that if you buy 20 that the probability will increase or anything like that. So that's an important distinction to make. And the last thing that I would put in here, just going back to what I suggested before as to why it's binomial, there are two possible outcomes. in that you have bent palings and you have non-bent palings. So that's how I'd write this out, non-bent. You've related it back to the scenario by putting those values in. And I'll go on to the next slide to work out the part B of this. Okay, on to the second slide. This shouldn't take too long. Calculate the probability that Elizabeth and John will have sufficient quality fence palings for the fence. So at least 130 non-bent. So all non-bent, so that's important, fence palings. So you'll remember on the previous screen that the probability of getting a bent fence paling was equal to 0.1. So therefore the probability of getting non-bent is equal to 0, oops, put a thing there, is equal to 0.9, so that's important. You'll notice that they purchased 150 palings. So in terms of our binomial distribution, because we've said it's binomial, this would equal our number of trials. Okay, and then our x value, since they want at least 130 non-bent, our x is equal to 130. So we go on to, so therefore go on to graphics calculator and go to your binomial screen and fill in all the above data, and it should look like what I put up on screen now. So I'll just move that around. So there we go. So you can see here that we've got our x, which is 130, our number of trials is 150, and our p-value is 0.9 because we're looking for non-bent values. But also we've got to remember, so what this is saying is that we're wanting at least 130 non-bent. So in terms of a probability statement, I've just thought of something here. The probability that x is at least 130, so 130 is greater than 130. The trouble is, of course, a binomial starts at 0. Now I'm not going to write from 0, 1, 2, all the way up to 150. I'm not going to do that. So you just have to imagine that if I put 130 in here, we're looking for that part there. But the graphics calculator works out that part there. So we need to work out, since we want at least 130, we need to say 129 or even 129.9. I mean, it shouldn't make that much difference, but we need that. We've worked out here what is less than 130. So the probability of x being less than 130, or less than or equal to 130, is equal to 0.072. But of course, we want more than that. So we need to actually go 1 minus 0.072, and that gets us a totally different answer. So hang on, that would give us 0.9218 basically. Whoops, is that right? Yeah. So that's your answer there. So there's basically a 92% chance that they're going to get at least 130 non-bent palings. Now, one thing here you're dealing with is just something to be aware of, that you could have easily made this number here 130 to 129.5, and that would have been preferable. Even though these numbers are so large, it wouldn't have had a final effect on this number, is because it said at least, and there's some feeling that this could be some sort of continuity correction sort of question, but these days that's usually to do with triangular or normal distribution. But either way would give you roughly the same answer anyway. At the end of the day as well, this is probably an example of a merit question.